Watch the rotation of this wheel. As a strobe light flashes over the surface, the wheel appears to slow down, stop, and slowly reverse direction. This trick of the eye has a deep history. In this photograph, a man uses a phenakistoscope mirror, demonstrating how slicing continuous motion into discrete frames can freeze a spinning object in place. This is apparent stasis, when the timing of the sample perfectly matches the speed of the wheel. But this stillness is a property of the observer, not the object. A wheel that looks frozen to the eye still carries its full angular momentum. Its physical reality remains unchanged and potentially dangerous. But physics operates beneath this visual surface. We confirm the reality of rotation through invariants like the Sagnac phase difference, a measurable shift in light that ignores how the wheel looks. This gyroscope stays upright because its angular momentum is a concrete physical fact. It persists regardless of the frequency of the light hitting it. The reason we see an illusion at all is the Shannon-Nyquist limit. It defines the boundary of our observation, where we only process the world in discrete, separated samples. The observer-dependent theory of everything, or ODTOE, provides the mathematical framework to bridge this gap between our samples and the underlying physics. ODTOE suggests that the static reading and the rotating reading are not a paradox, but two different projections of one single object. In this view, any observation of motion is a two-part system, the physical disk itself and the specific frequency at which the observer captures it. This is level 1 reality, the surface-level reading that changes whenever the observer's sampling frequency shifts. To find the truth, we have to distinguish between the artifacts of our own observation and the invariant laws of the universe. This diagram maps observation frequencies. A single sample rate restricts us to one affine chart. At 0, the strobe matches rotation, creating apparent stasis. Approaching infinity, the disk is sampled so rapidly it appears everywhere at once. These two states, stasis and omnipresence, look like opposites, but they are simply the two extreme boundaries of our observational chart. ODTOE uses projective geometry to connect these extremes, treating infinite limits differently than standard math. We start with a straight line of observation frequencies, from 0 to infinity. Through the Möbius inversion, we bend this line into a curve. The inversion glues 0 and infinity together, creating a closed projective loop. Here, stasis and omnipresence are no longer opposites. They meet at a single invariant projective point. This loop is the complete basis. Unlike a single chart seeing one frequency at a time, the complete basis accounts for the entire spectrum of all possible observations. When we shift from our limited sample rate to this complete mathematical view, the illusion of the frozen wheel collapses. By accounting for the geometry of the entire loop, we can mathematically strip away the observer's limitations and expose the raw mechanics underneath. This deeper layer is level 2 and level 3 reality. These are the structural invariants, the physical truths that remain the same no matter how we choose to sample them. We see this in the Lense Thirring effect, where a rotating mass is so powerful it literally drags the fabric of spacetime along with it. This kind of motion isn't a trick of the light. It is an invariant property that alters the geometry of the universe itself, regardless of who is watching. But a problem arises when we try to reconstruct this continuous physical rotation using our limited discrete samples. As this diagram shows, when we use discrete steps to track a continuous circle, they don't perfectly align. This structural discrepancy is known as the spiral residue. This gap isn't random. It represents the difference between a circle's transcendental circumference, pi, and its simplest discrete approximation, which is the number 3. ODTOE defines this gap as exactly pi minus 3 squared, roughly 0.0200. This numerical value is a fundamental constant in the theory. It is the mathematical signature left behind whenever a discrete observer tries to record a continuous universe. Our physics can be invariant, but our data is always sampled. To find true reality, we must understand the mathematical limits of our own perspective.